back to the real number system. In this video, we're going to talk about section 5.2. Through section 5.2, we'll look at our models for multiplication of integers. We'll look at the properties of multiplication of integers. We'll look at integer division, and we'll also look at the order of operations. So let's get started. Our first model for integer multiplication is our CHIP, or our charge field model. Now, our first factor tells us how many groups. The first factor, if it's positive, tells us to add. And if the first factor is negative, we take away these groups. The second factor tells us how many chips and the color or the signs of the chips. For example, let's suppose we want to find 3 times negative 2. The first number is positive, so we add 3 groups of 2. The 3 tells us how many groups, the 3 groups. And the negative 2 tells us that we're adding the red chips. So notice in our picture we have 3 groups of 2 red chips. But let's suppose we want to find negative 3 times negative 2. Well, the first number is negative, so this tells me I'm going to take away chips. The 3 tells me how many groups, so I'm going to take away 3 groups. And the second number tells me what type of chips. So I'm going to have negative chips, and there are going to be 2 negatives in each group. Now we always start with 0. 3 times 2 is 6, so I need at least 6 red chips or 6 negatives. I start with 0, so I start with 6 negatives and 6 positives. This is 0. Then I'm going to take away 3 groups of 2 negatives. And I'm left with the 6 positives. Let's look at some more examples. Let's suppose that we want to illustrate each of the following using chips. So here we have 2 times negative 4. Well, the positive 2 tells us we're going to add, and we're adding 2 groups. The negative 4 tells us how many are in each group and what's in each group. So 4 negatives in each group. So I draw my set. And I'm going to add 2 groups of 4 negatives to that set. So here's one group of 4 negatives, and here's a second group of 4 negatives. There's a total of 8 negatives, and so my answer here would be negative 8. Let's look at another. So let's suppose we have 4 times 2. The first number is positive, so that tells me to add. And the first number also tells me how many groups, so I'm adding 4 groups. The second number tells me how many are in the groups and whether I have positives or negatives. So here I have 2 positives in each group. So draw your set, and then I'm going to add 4 groups of 2 positives. So here's a group of 2 positives, 2 groups, 3 groups, and 4 groups of 2 positives. That gives me 8 positives for a total of positive 8. Now look at part C. Here we have negative 3 times 4. This time our first number is negative, so this tells us to take away. I'm going to take away 3 groups, and the second number tells me what's in each group. So in each group I have 4 positives. I always start with 0. To represent 0, I can use a positive and a negative, so let's start with that. I need 3 groups, and I need 4 positives and 4 negatives in each group. So here's one group of positives and negatives, one group of 0. Here's a second group of 0, and a third group of 0. Now notice that I have 3 groups of 4 positives that I can take away. So I'm going to take away one group of 4 positives. Notice that I circled it and drew an arrow pointing out to show that I'm taking that group away. Here's my second group of 4 positives that I'm taking away, and my third group of 4 positives that I take away. This leaves me with 12 negatives in my set. And so my answer here is negative 12. Look at part D. Here we have negative 5 times negative 2. My first number is negative, so that tells me to take away. And the first number also tells me how many groups, so I'm going to take away 5 groups. The second number tells me what's in each group. Well, in each group, I have 2 negatives. We always start with 0. Now, I need 5 groups to represent 0. I can use positives and negatives. And notice I'm looking at groups of 2 here. So I have 1 group of 0, 2 groups of 0, 3 groups of 0, 4 groups of 0, and 5 groups of 0. When I have a plus and a minus together, that makes 0. Now, notice that I now have 5 groups of 2 negatives that I can take away. So I'm going to take away my first group. I circled it and drew an arrow out of the circle to show that I'm taking that group away. Here's my second group I take away, third group, fourth group, and fifth group. In my set, I'm left with 10 positives, and so my answer here is positive 10. Our next model for multiplication is our number line model. Our same rules from addition apply for multiplication. So we always start at 0. If our number is positive, we're going to walk forward. That means our arrow is going to go to the right. And if our number is negative, we walk backwards, and so our arrow points to the left. For example, here we have 2 times negative 3. This tells us to take 2 jumps of 3 to the left. So notice we have our 2 jumps of 3 to the left. Now here we have negative 2 times negative 3. The negative 2 tells us the opposite. And then notice too, we have 2 jumps of 3 to the left. So here we have our 2 jumps of 3 to the left, and then we take the opposite of that. So the opposite of negative 6 is 6. Let's look at some more examples. In part A, we have 2 times negative 4. So this tells us the 2, we're going to take 2 jumps, and the second number tells us which direction and how long. So 2 jumps of 4, and since our 4 is negative, we jump to the left. Now because I'm looking at jumping to the left here, I'm just going to put the negative numbers on my number line. I'm going to count from negative 10 to 0. If you don't make your number line long enough, you can always go back and add numbers in either direction to your number line. So I take 2 jumps of 4 to the left. Start at 0, and I jump 4 to the left, and then my second jump of 4 to the left, and notice we land on negative 8. And so my answer here is negative 8. Look at part B. We have 4 times 2. So the 4 tells us how many jumps. We're going to take 4 jumps. The 2 tells us how long and which direction. So 4 jumps of 2 to the right. This time we jump to the right because that 2, the second number, is positive. Now because I'm jumping to the right, I'm going to start at 0 and count to 10 on the number line. Then I take my jumps. So here's my first jump of 2, my second jump of 2, my third jump, and my fourth jump. Notice that we land on 8, and so my answer here is 8. Look at part C. Part C has negative 3 times 4. Because the first number is negative, this tells me to take the opposite. The 3 tells me how many jumps, so the opposite of 3 jumps. The 4 tells me how long and which direction. So 3 jumps of 4 to the right. And I jump to the right because the 4 is positive. On my number line this time, because I'm taking the opposite, I'm going to include both positive and negative numbers on my number line. And I'm going to count from negative 12 to 12. We start at 0, and I take 3 jumps of 4 to the right. So here's 1 jump of 4, 2 jumps of 4, and 3 jumps of 4, and we land at 12. But remember, we have to take the opposite of 12. And so the opposite of 12 would be negative 12, and my answer here is negative 12. Let's look at one more. Negative 5 times negative 2. The negative 5, that negative tells me to take the opposite, and the 5 tells me how many jumps. The second number tells me how long my jumps are and which direction. So 5 jumps of 2, and I'm jumping to the left this time because the second number is negative. Again, because I'm taking the opposite, I'm going to include both positive and negative numbers on my number line. I start at 0, and I'm going to take 5 jumps of 2 to the left. So here's 1 jump of 2, 2 jumps, 3, 4, 5 jumps of 2 to the left. And notice that we land at negative 10. But once again, I'm taking the opposite of this. So the opposite of negative 10 would be positive 10. And my answer here is 10. Our next model for multiplication is our pattern model. So let's look at a football game. And let's suppose that a running back lost 2 yards on each of 3 carries in the game. So we have negative 2 plus negative 2 plus negative 2. We saw in our last section that this would be negative 6. Now I can represent this with multiplication. We have 3 carries and we lose 2 yards on each carry. So 3 times negative 2, and our answer is negative 6. Our commutative property holds for multiplication of integers. So I can rewrite negative 2 times 3 as 3 times negative 2, which we just saw is negative 6. Now let's use patterns to complete the following multiplications. So notice my second factor every time is negative 2. We just saw that 3 times negative 2 is negative 6. I could use a number line and find 2 times negative 2, it would be negative 4. 1 is our multiplicative identity. When I multiply 1 times any number, I get that number. So 1 times negative 2 is negative 2. 0 times any number is always 0. So 0 times negative 2 is 0. Now notice here, my first factor has decreased by 1 from line to line. It is increasing by 2. So let's continue our pattern. So negative 1 times negative 2 would be a positive 2. Negative 2 times negative 2 is positive 4. And negative 3 times negative 2 is positive 6. Just like we saw with addition and subtraction, sometimes patterns can help children understand our multiplication of integers. Now, let's look at our properties for integer multiplication. Our closure property of multiplication holds for integers. That means when I multiply 2 integers, I get a unique integer. The commutative property holds for multiplication of integers. We saw this earlier. 3 times negative 2 is the same thing as negative 2 times 3. Order doesn't matter for multiplication. Our third property is our associative property. Remember, the associative property changes our grouping. Next, we have our identity property. We saw in our patterns that 1 is our multiplicative identity. 1 times negative 2 is negative 2. We also have our distributive property. And we have our 0 multiplication property. When I multiply times 0, my answer is 0. Now this brings us to some new properties. So let's say I have negative 1 times a. That's going to be negative a. In other words, when I multiply by negative 1, I take the opposite of my number. Negative a times b, we have our commutative property, so that's the same thing as b times negative a. And notice this is the opposite of a times b, so that negative a times b is the opposite of a times b. Negative a times negative b, negative times a negative makes a positive when we multiply. So negative a times negative b is ab. We also have our distributive property of multiplication over subtraction. So let's look at distributing. Negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. Look at part B. So here we're distributing, but our number's on the right. So we'd say negative 4 times x is negative 4x, and negative 4 times 4 is negative 16. This brings us to division. We've talked about the definition of division before. A divided by B equals C if B times C equals A. And notice that C does need to be a unique integer. For right now, our quotients will be integers. We'll look in chapter 6 at what happens if our quotients are not integers. Let's use the definition of integer division to evaluate each of the following. So 12 divided by negative 4. I ask myself, negative 4 times what makes 12? Well, I know that 4 times 3 is 12. I have to decide if I need a negative or a positive. A negative times a negative makes a positive. My answer is positive. So that tells me I need negative 3. Negative 4 times negative 3 makes positive 12. Part B, we have negative 12 divided by 4. So 4 times what makes negative 12? Again, I know that 4 times 3 makes 12, and I need to decide if this is a positive 3 or a negative 3. My answer is negative. My first factor is positive, so 3 has to be a negative. 4 times negative 3 makes negative 12. Part C, negative 12 divided by negative 4. I ask myself, negative 4 times what makes negative 12? Well, again, I know 4 times 3 is 12, and I need to decide if that 3 is positive or negative. Well, notice my first factor is negative. My answer is negative, and so the 3 has to be positive. Negative 4 times 3 makes negative 12. So hopefully you noticed that when we had a quotient of two negative integers, our answer was positive, as in that last example. However, if we have a positive and a negative, that quotient is going to be negative. We use the order of operations with integers. Remember PEMDAS. P stands for parentheses. E stands for exponents. M and D is multiplication and division from left to right. And the A and the S is the addition and subtraction in order from left to right. Look at part A. We don't have any parentheses to simplify, neither do we have any exponents. So I start with my multiplication and division from left to right. Negative 16 divided by 4 is negative 4. Bring down the rest of your problem. I still have multiplication. So negative 4 times 2 is negative 8. Bring down the rest of your problem. And then we add from left to right. 2 plus negative 8 is negative 6. Plus 8 would be 2. In part B, we have negative 3 in parentheses to the fourth power. Well, that fourth power tells me I multiply negative 3 times negative 3 times negative 3 times negative 3. That I'm going to multiply from left to right. Negative 3 times negative 3 is 9. Bring down the rest of your problem. 9 times negative 3 is negative 27. Bring down the rest of your problem. And a negative 27 times a negative 3 is a positive 81. Now notice here, when I have a negative raised to an even power, my answer was positive. And part C, we have negative 3 to the fourth. This one is different because the negative is not in parentheses. So at the end, I'm going to take the opposite. So 3 to the fourth is 3 times 3 times 3 times 3. And we just saw that 3 times 3 times 3 times 3 is 81. And don't forget, we're going to take the opposite of that. And so our answer here is negative 81.